Okay, ladies and gentlemen, by request of one of your very own, I've been asked to make a video for formulas and naming, and so here we go. The first thing I'm going to talk about are the types of formulas: molecular, structural, and empirical, using ethane as an example. Molecular formulas are the most common that we'll see throughout the chemistry curriculum. C2H6 simply tells you how many atoms there are. Structural formula shows how the atoms are bonded, versus empirical formula, CH3, it's the reduced simplified form of the molecular formula. Looking at C2H6 as our original formula, you factor out 2 because it's the greatest common factor, and then you divide it by 2, you get CH3 as your empirical formula. Alright, now we're going to figure out how to count atoms when given a formula. First, we need to know that the subscripts give the number of atoms, the coefficients give the number of compounds, and the parentheses are only used around polyatomic ions. And let's take a look at some of these examples. Na2O. The 2 is the subscript, tells us there are 2 NAs and then 1 O. Coefficient, 5 for H2O. The 5 is our coefficient, tells us there are 5 H2Os. That gives us a total of 10 H's and 5 O's. Now the next one, NH4,2O, shows a parentheses around the NH4. NH4 is our polyatomic ion, and that subscript 2 tells us there are 2 NH4s. As a result, we get 2 nitrogens, 8 hydrogens, and 1 oxygen. Now if you look at the last example, MgSO4, we don't need parentheses around the SO4 even though it's a polyatomic ion, and that's because there's no subscript needed around the SO4. We only have one set of SO4. We're going to look into binary or ionic compounds. Binary meaning there are 2 ions together. Ionic compounds only consist of metals and nonmetals together. And we use the crisscross method. So you crisscross the charges down as subscripts, or in the reverse, subscripts crisscross back up to charges. Alright, and important notes is that we have endings for the names. We have "-ide" for elements, and if there are polyatomic ions, you keep the names. So let's start with a few examples for formula writing. So here, 1, 2, and 3, sodium chloride, lithium phosphide, and aluminum oxide. So first you need to identify their ions. Their oxidation charges come from the reference table. And then you crisscross them downwards to find the subscripts, and then you remove the subscripts if it's just one. And you pretty much finalize and simplify the formula as such. In terms of naming, you're going to crisscross those subscripts back up to the top to get their oxidation charges, so that way you're able to figure out what elements they are. It's a little easy when they only have one oxidation state. And so you could take a look at those bottom 2 examples, try them on your own, and you'll get calcium bromide and aluminum carbonate as your names. Now what happens if the cation has multiple oxidation states? So that means we have to use Roman numerals to indicate which oxidation state they are. So Roman numerals off to the right side, I listed them there from 1 to 10, what they look like in case you don't know. And then here are some examples here. In the case where if your metals have multiple oxidation states, that's when you use the Roman numeral. And those Roman numerals indicate the charge, not the order in which they are listed on the table. It's the charge. So if it's a Roman numeral 2, it's a 2+. If it's a Roman numeral 3, it's a 3+. Not the 3rd oxidation state or the 2nd oxidation state listed there. Okay? And so you still employ the crisscross method so that you could figure out the name and also what ions you got to use. Okay. So I also left some examples there for you guys to try out. Slowly follow along and hopefully you'll get this through. So as you can see here, I'm going to work through the manganese 7 oxide and the manganese 3 chloride. So 7 oxide, that's a Roman numeral 7, so it's a 7+ for manganese. Identify the symbols, crisscross them down, and you get Mn2O7. Now manganese 3 chloride, 3 means the 3+, chloride is minus, crisscross them down, you get MnCl3. This last slide is going to go over what's probably the easiest of them. Covalent compounds, and they use prefixes to tell us the number of atoms. Remember that covalent compounds only have nonmetals, and you don't have to reduce this to empirical form. So if there's no prefix, it's understood that there's only one, and the second element must have a prefix. And so the prefixes are shown to the right: mono, di, tri, tetra, penta, hexa, hepta, octa, mono, and deca. Oh, sorry, that was not mono, that was nona. Okay. So let's take a look at some of these examples: CO2, H2O, dinitrogen pentoxide, carbon tetrachloride, and CO. So notice carbon in the name, carbon dioxide. There's no prefix attached to carbon, so it's understood to be 1. But if you look at the next example, dihydrogen monoxide, we need a prefix there because it's the second element listed in the compound. Sorry. And so dinitrogen pentoxide, di is 2, penta is 5, so N2O5, tetra is 4, so CCl4, and carbon monoxide, so notice the difference there. Carbon is the first element, so it doesn't need a prefix, and then monoxide, oxygen, needs the prefix because it's the second element listed. Alright, I hope that was helpful. Good luck tomorrow on the quiz, guys.